Discrete Fourier transform. In this chapter, we'll discuss about computations in DFT. Computations in DFT in calculation of discrete Fourier transform by DFT formula. Whenever we evaluate this equation, we actually multiply the values of x of n with Twiddle factor w term, and by adding the values we get x of k. Since w term, Twiddle factor w term is a complex term, we will assume that x of n is also complex and calculate the total number of complex multiplications and complex additions involved in calculations of DFT. So the total complex multiplications are n square and total complex additions are n square minus n. Let's do this in detail. Let's find complex multiplications and complex additions involved in DFT calculations. So by DFT formula, if we expand this summation term, say for n equal to 4, we get 4 terms to be added. In every term, 2 numbers are multiplied. Assuming x of n complex, total number of complex multiplication in this expression are 4 and total number of complex additions are 3. 3 times you have to add these 4 numbers. In general, number of complex multiplications are n and number of complex additions are n minus 1. Now to find all values of x of k, let's take one example. We multiply this. To find one value of x of k, we have to multiply n times. To find all n values of x of k, we have to multiply it n square. So total complex multiplications in calculation of all n values of x of k are n square and total complex additions are n times n minus 1. Let's do this analysis to find real multiplications and real additions involved in whole calculations. Now we know that total complex multiplications are n square. So let's consider two complex numbers p and q. When we multiply this p and q, we get this final expression where a, b, c, d are actually real values. So ac minus bd is a real number, bc plus ad is another real number. Here we are multiplying 1, 2, 3, 4 times and adding 2 times. So there are 4 real multiplications and 2 real additions in this entire expression. When 2 complex multiplications happen, there are 4 real multiplications, 1, 2, 3, 4 and 2 real additions. This real number is subtracted, means added here, and these numbers are added here. So total 2 real additions. When we add 2 complex numbers, we actually add 2 times and there are no multiplication, 2 real additions. This one and this one. So for 1 complex additions, we get 2 real additions. Let's now take DFT example where there are total n square complex multiplication. We concluded that for 1 complex multiplication, we require 4 real multiplications and 2 real additions. For n square complex multiplication, we will require 4n square real multiplications and 2n square real additions. Similarly, total complex additions are n times n minus 1. So total real additions would be n square minus n multiplied by 2. Adding this additions and real additions, we get total real multiplications 4n square and total real additions 4n square minus 2n.
Course is an online learning platform designed to provide high quality, structured education in a flexible and accessible way. The platform offers academics and professional courses across technology, management, entrepreneurship, science, and engineering. Each course is created by experts and includes video lectures, assessments, and certificates to ensure clear and measurable learning outcomes. Don't forget to visit www.course.z.
Thank you.